Imagine a world without banks, where trust is built into the very fabric of transactions. A world where intermediaries are no longer needed, and every transaction is secure, transparent, and direct. This is the promise of blockchain, a revolutionary technology that is transforming the way we exchange value and information. Blockchain is not just a buzzword, it is a paradigm shift that is redefining the very essence of trust and security in the digital age. At its core, blockchain is a decentralized ledger, a digital record-keeping system that is not controlled by any single entity. This means that no central authority, like a bank or government, has control over the data. Instead, it is distributed across a network of computers, making it virtually impossible to tamper with. Each computer, or node, in the network holds a copy of the entire blockchain, ensuring that the data is always available and secure. This distributed nature ensures transparency and security as every participant has access to the same information. Any changes to the data must be agreed upon by the majority of the network, making unauthorized alterations extremely difficult. This information is stored in blocks, which are like digital containers for data. Each block contains a list of transactions, a timestamp, and a reference to the previous block, creating a continuous and unbroken chain. These blocks are linked together in a chronological order, forming a chain of information that is constantly growing. This chain is immutable, meaning once data is recorded, it cannot be changed or deleted. This is the essence of blockchain, a secure, transparent, and tamper-proof way to track and verify transactions. Every transaction is recorded and verified by the network, ensuring its authenticity and integrity. This groundbreaking technology has the potential to revolutionize a wide range of industries, from finance and supply chain management to healthcare and government. In finance, blockchain can streamline processes, reduce fraud, and increase transparency. In supply chain management, it can provide real-time tracking and verification of goods. In this essay, we will delve into the fundamentals of blockchain, exploring its inner workings and real-world applications. We will uncover how blockchain works, the different types of blockchains, and the various consensus mechanisms that ensure its security. We will also examine the potential benefits and challenges of this transformative technology. While blockchain offers numerous advantages such as increased security and transparency, it also faces challenges like scalability, energy consumption, and regulatory hurdles. Join me on a journey to unravel the mysteries of blockchain and discover its power to reshape our digital world. Together, we will explore how this technology can create a more secure, transparent, and efficient future for all.
At its heart, blockchain is all about record keeping. It's a revolutionary way to document and verify transactions in a secure and transparent manner. It's like a giant digital ledger that keeps track of every transaction made. Imagine a massive, ever-growing spreadsheet that is accessible to everyone in the network. But unlike traditional ledgers, which are centralized and controlled by a single authority, blockchain is distributed. This means no single entity has control over the entire ledger. This means that the ledger is copied and spread across a network of computers. Each computer or node in the network has a copy of the entire ledger. Imagine a book where every page represents a block of transactions. Each block contains a list of transactions that have been verified and approved by the network. Each time a transaction occurs, it's like writing it down on a page in this book. The transaction is then verified by multiple nodes in the network to ensure its validity. Once the page is full, it's added to the book and linked to the previous page, forming a chain of blocks, hence the name blockchain. This chain is immutable, meaning once a block is added, it cannot be altered. This decentralized approach offers several advantages. It ensures that no single point of failure can compromise the entire system. First, it eliminates the need for a central authority, such as a bank or government, to oversee transactions. This reduces the risk of corruption and fraud. Second, it makes the system incredibly secure. The distributed nature of the ledger means that even if one node is compromised, the rest of the network remains secure. Because the ledger is distributed across many computers, it's virtually impossible for a single entity to alter or corrupt the data. Any attempt to change a transaction would require altering every copy of the ledger simultaneously, which is practically impossible. Every change to the ledger is recorded and reflected across all copies, ensuring transparency and accountability. This means that all participants in the network can see and verify every transaction. This makes blockchain an ideal solution for applications where trust and security are paramount, such as financial transactions, supply chain management, and digital identity verification. By providing a transparent and secure way to record and verify transactions, blockchain technology has the potential to revolutionize many industries. As we continue to explore and develop this technology, the possibilities for its application are virtually limitless. From healthcare to real estate, blockchain is poised to transform the way we conduct business and manage information.
The true ingenuity of blockchain lies in how these blocks are linked together. This linking mechanism is what sets blockchain apart from other data storage technologies, providing a robust and secure way to manage information. Each block contains a unique code called a hash, which acts like a digital fingerprint. This hash is a string of characters that is generated by processing the block's data through a cryptographic algorithm. This hash is created using a complex mathematical algorithm that takes into account all the data within the block. The algorithm ensures that even a tiny change in the block's data will result in a completely different hash, making it highly sensitive to alterations. When a new block is added to the blockchain, it's linked to the previous block using its hash. This means that each block carries a reference to the hash of the block before it, creating a continuous chain. This creates a chronological chain of blocks, where each block is inextricably linked to the one before it. The chain grows over time as new blocks are added, forming a secure and immutable ledger of transactions. This interconnectedness is what makes blockchain so secure. Each block's hash is dependent on the data within it and the hash of the previous block, creating a web of interdependencies that is extremely difficult to break. If someone tries to tamper with the data in a block, its hash will change. This change will cascade through the subsequent blocks, altering their hashes as well. This change will be immediately obvious to everyone on the network, as the altered block will no longer match the hash recorded in the subsequent block. The network participants can then quickly identify and reject the tampered block. This makes it virtually impossible to alter the blockchain without being detected. The decentralized nature of the network means that no single entity has control over the entire blockchain, adding another layer of security. This tamper-proof nature of blockchain has profound implications for security and trust. It ensures that once data is recorded, it cannot be altered or deleted without leaving a trace. It provides a reliable and transparent way to track transactions, verify data integrity, and prevent fraud. Every transaction is recorded in a public ledger that is accessible to all network participants, ensuring transparency and accountability. From tracking the origins of food products to securing digital identities, the potential applications of blockchain are vast and still being explored. Industries such as finance, healthcare, and supply chain management are already leveraging blockchain technology to enhance security, efficiency, and transparency.
Miners, the guardians of the blockchain. We've established that blockchain is a decentralized ledger, but who maintains this ledger? This is where miners come in. Miners are individuals or groups who use specialized computers to solve complex mathematical problems. These problems are designed to be difficult to solve, requiring significant computational power. The first miner to solve the problem gets to add the next block of transactions to the blockchain. This process is known as mining. Miners are rewarded for their efforts with cryptocurrency, the digital currency that powers many blockchains. This competitive process ensures that the blockchain remains secure. Since miners are incentivized to act honestly, they are unlikely to validate fraudulent transactions. If they do, they risk losing their reward and damaging the integrity of the blockchain. The work of miners is crucial to the functioning of blockchain. They act as the guardians of the network, ensuring its security and reliability. Their efforts are essential for maintaining trust and transparency in the system.
Cryptography. Securing the digital Fort Knox. Cryptography is the backbone of blockchain security. It ensures that transactions are secure and tamper-proof. But how does it work? At its core, cryptography uses complex mathematical algorithms to encrypt data, making it unreadable without the correct key. Imagine a locked box with a unique key. Only someone with the matching key can open the box and access its contents. In blockchain, this key is a pair of mathematically linked cryptographic keys, a public key and a private key. Your public key is like your bank account number. You can share it with anyone, and they can use it to send you transactions. Your private key, however, is like your PIN code. It must be kept secret, as it allows you to authorize transactions from your account. This combination of public and private keys ensures that only the rightful owner can access and manage their funds. It also helps prevent double spending, a common problem in digital currencies. Cryptography is the invisible force that safeguards the blockchain, making it one of the most secure technologies ever invented.